Hello, my name is Wenhu Chen. Today I'm going to talk about my WACV 2021 paper, Meta-Module Network for Compositional Visual Reasoning. This is a joint work between University of California, Santa Barbara and Microsoft AI and Cloud. So, as we all know, the spiral question answering problem has recently drawn a lot of attention from the AI community. So the problem is to answer a question given an image. For example, in this case, a question about what is the mustache made of is asked by the human, and the machine needs to resolve to the image to answer the question with bananas. Recently, in order to improve the explainability of question answering in visual domain, people have proposed neural module networks. So the pros of this neural module network is that it uses instance-wise compositional networks for different queries. And this neural module networks has a very strong compositionality and explainability, which means that even though the model does not see a exact composition in the training time, it can still generalize to a certain kind of composition in test time. That's why this neural module networks has gained a lot of popularity recently. But there are some cons about this neural module networks. So the first one is it lacks generalization. It has a rigid design of module network, which makes it fail to generalize to out-of-domain functions. And it also lacks scalability. The customized modules are hard to design for specific purposes, which makes the model hard to scale up. So our idea is to combine the meta-learning with meta-module network so that the model doesn't require any hand design for the module network. The model can learn to learn the module network by itself. And this meta function takes a function description to instantiate instance modules, and then compose these instance modules together as a module network. So in the first phase of this model, we need to first parse this user query into a semantic form. For example, in the query of who is blah 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 is parsed into the semantic tree on the right-hand side, which first select the ball and then relate to some of the nearby items, and then finally choose which one is older. The second one is the core part of this meta-module network. So this meta-module network has a transformer backbone, and then it takes a function description recipe as the input. And depending on the different recipe, the transformer will boil down to different functions. For example, if it receives a function of relate, it will boil down to the left-hand side function. If it receives a recipe of filter, it will boil down to the right-hand side function to perform different functionality in visual reasoning. And then after we instantiate all of these different modules, we can compose them like the semantic graph that we parse from the query. And then in the final hidden layer, we will predict the answer as the final question answer. So in order to help this meta-module network learn, we use a symbolic teacher to teach it to reason about the intermediate steps. So here is our result. We can improve over the neural module network by a large margin of 5% accuracy. And this is some interesting examples where our model learns to reason in the intermediate steps to get the results. Finally, we combine the meta-learning with neural module networks to propose this meta-module network. improve the module network significantly on more complex GQA dataset. Thanks.